Hi, this is Katelyn Liu, and today I'll be going through the 6th grade worksheets for lesson 34. So the first worksheet you should have gotten asks us to solve the equation, solving for the variable, and to show our work, and also to check our answers. So these are pretty straightforward. You want to do the inverse operation in order to get rid of the number that we don't want here. So the variable here is x. And you don't want the 7 because we just want to see what x equals. So we want to minus the 7 from both sides because in this problem, they're adding the 7. So if we minus the 7 from both sides, right, 7 minus 7 equals to 0. You can bring the x back down, bring the equal sign back down, 24. Minus 7 would equal 17. Now to check our answers, we can just use this original equation, and instead of writing the x, we write it for 17, since supposedly, as we figured out, x is equal to 17. Now 17 plus 7 is equal to 24. Is that correct? Yes, that's correct. So now we know that our answer is correct. Number 2 is the same concept. You want to minus 51 from both sides. This gives us 0. X is equal to 17 minus 51, which would be, 51 minus 17 gives us 34. Now it's negative 34. Okay, now we have negative 34 plus 51 is equal to 17. Is that true or false? That is true. Okay, this one is pretty straightforward because it's like any other addition problem that you will ever have. It just is asking us to find out what 94 plus 50 equals, because whatever that number is equal to x. So we can just think of this as 90 plus 50, which gives us 140, and add 4. So we have 144. Okay, number 4 is asking us what 25 minus 81 is. Let's see. 81 minus 25 gives us x is equal to negative 56. This next one is an addition problem because we get rid of this on both sides by adding it. So x is equal to 282. If you plug that back in, it should be correct. And this one is a little more difficult. We want to minus the 19 on both sides. Cancel this out. Negative 11x is equal to, let's see, 5. Now x is equal to, oh, my bad. We want to divide both sides by negative 11 because the x is being multiplied by negative 11. We want to do the inverse operation. And now x is equal to negative 6. Plug that back in and you will find that that is true as well. Alright, so the second worksheet asks us to solve the inequalities, which is almost the same, except we have to worry about this inequality sign and to show our work as well. So the first one is long division, so I'm not going to do it because it'll take a while. Just the concept is you want to divide by 41 on both sides. Now you get x is greater than whatever 287 over 41 is equal to. Now the second one, let's see. When you're looking at problems like these that have multiple operations being done to the x, you want to see what you can undo without completely making it very, very complicated. For example, if you divide both sides by 2, once you see the 2, you're going to be left with, so you have x plus 91 divided by 2, which is 45.5. That's not true. Wait. Yes, that is true. And 3 is greater than 311 over 2, which is just a complete mess. What you can do instead is subtract the 91 here first. So you get 2x is greater than 311 minus 91 is equal to 2, 3, oh, actually, it's 2, 4. Is that correct? I don't know if that's correct. Oops. What's a 0? 120, okay. And then from here you can divide both sides by 2, which gives x is greater than 60. Yeah. Okay. So the rest of the page is basically the same as we've been doing. The only thing that you have to watch out for is the negative sign. So I'm going to write a little example on the side, and then when you come across it, you can work around it. So let's say you have negative 4x is greater than 8, and you want to divide by negative 4 on both sides, right? Well, the issue with this is that when you divide or multiply by a negative sign, you have to switch the sign of the side. For example, this one would equal x is less than negative 2. All you have to do is switch the sign, but you always have to remember that whenever you divide or multiply by a negative on both sides of an inequality, the sign changes. Okay, this one, and I believe the last page is asking us to identify the sequence and write the next 3 terms in the sequence. So, number 1 can be interpreted in a couple different ways. You can say that you're adding 2, right? But you can also say that they're multiples of 2, both of which are correct. So it'd be 2, 4, 6. You want to add 2, then that would be 8. Add 2. Actually, we don't even need to write 2 for 6. 2 for 6, 8, 10, 12. And the second one, you can either say that we're adding 3 to each one or that they are multiples of 3, but we're just going to say that we can go by each one. This one I went by you're adding 2. This one I'd say multiples of 3. So you know multiples of 3, 6, 9, 12, 15, and 18, and so forth. This one, we can look at the difference between these numbers, and we can say that they're adding 2 on both, increasing by 2. So 21 plus 2 equals 23, 23 plus 2 equals 25, and 25 plus 2 equals 27. On this one, you can see that they're subtracting 6, a little bit different. And so 24 minus 6 is 18, 18 minus 6 is 12, 12 minus 6 is 6. Alright, and the last page is pretty much the same. This one's easy one. 10, 20, 30, 40, 50, and 60. This one you can say 1 to 2 you add 1, and you add 2, so maybe, and the next one you add 3, so 4 plus 3 equals 7, and then 7 plus 4 would be 11, and 11 plus 5 would be 16. This one 102 to 6, okay, this is pretty straightforward. 108, 110, and 112. Oops. And the last two I trust that you can figure out on your own.